Greetings, I am Maleficious, and I'm back with more of Shenzhen IO. Don't have any tea tonight, just water, but it should still be pretty good. Yeah, tasty water. But yeah, this time, I've actually got two solutions lined up. One for a puzzle from last time, and one for a puzzle from a few weeks ago. So, how about we get right into that? Yep, I've come up with a solution for the precision food scale. And so here's how it works. So I've got an MC6000 here connected up to the two inputs and the LCD screen as well. So this one just kind of handles everything. Well, it handles the input and output, and this MC6000 handles the calculations. So, starting up here, the first thing I do is test equal if P0, the button, is 100, so if it's on. And if it is, I institute a NOT. So, if the accumulator is at 0, it goes to 100, otherwise it goes to 0. So, then I test if the accumulator is equal to 100, if it's on. And if it is, I move whatever is in P1 through the X2, and then I jump ahead to wait. So we'll hold off on that for now, because if it's not equal to 100, then that means it's either in an off state or it's in a reset state. So I'm testing if DAT is equal to negative 999, and I'm using the DAT on this microcontroller to store what's being outputted to the monitor currently. So if there's nothing right now, then I just jump to the end. Okay, so then I test if DAT registry is equal to 0, which means that we need to switch it off. So if it is, I move negative 999 into this calculator. Otherwise, I move a negative 1 into this microcontroller, and then I NOT the accumulator because it's at 0 right now, and I need to keep it on because this is a tear, or this switches it to this zeros this fine. Okay, so then we finally hit wait, and so the wait is to move X1 to DAT, and this is interesting. I've learned now that if I do this, then this microcontroller pretty much stops until it receives data from here. And that's useful because I didn't need to set it to sleep until it receives data from X1, so I was able to save one line of code and fit it all into the 14 lines here. So then this goes in, it goes to the DAT registry, and that shows whatever is supposed to be output. I move that to X3, and it goes to the LCD screen, and then I end by sleeping 1. Then this microcontroller, I set it to sleep until it receives data from the X0 port, so from this microcontroller. I move it to the accumulator. Then I test if it's equal to negative 999. If it is, I move 0 into this DAT, because I'm holding modifier in this DAT registry. Then I jump to the end. Then I test if the accumulator is equal to negative 1, in which case I'm zeroing the scale. So in that case, I multiply DAT. So I multiply the negative 1 in the accumulator by whatever's in the DAT registry, which should be whatever the output number was beforehand. Then I move the value in the accumulator into the DAT, so now I have the negative value in the DAT registry, and then I move 0 to the accumulator, and then I jump to the end. Then, if it's not negative 999 or negative 1, that means it's 0 to whatever, 100 at max, I think. So I test if the DAT is negative. If it is, I add the DAT to whatever's in the accumulator. And if it's not, I move whatever's in the accumulator into the DAT registry. So I'm storing whatever is supposed to come out. And at the end, I move the accumulator back into this one. And so that should work. So you see here, it's off, it stays off but it's coming on. So not, and then move it, it goes through, it comes back out, the screen turns on. So it keeps going like that, stays at 0. It goes up to 19 because now we have a weight on the scale. goes up to 32, 12, 0, and then it switches off, turns back on, 16, 32, and this is the point where it zeros, so yeah. So yeah, then -1 goes in, multiply by 32, move it in, now the modifier is -32, and that goes, yeah, now it's zeroed, 28, 49, 12, -32, zeroed, and off. So it seems to work pretty well, and it worked in the first 2 test runs, so I'll just run the simulator. Seems to be outputting the correct numbers. And I'm gonna have some more water. And there we go. Okay, so the most common cost was 4 or 5? Maybe 5. Which means 1 MC6000. Well, I'm not sure how exactly to do it that way, but I guess I hit the second most common cost. I'm still using a lot of power, and I'm still using a lot more code. But hey, I came up with this on my own, so I'm proud of that. Okay, from Precision Foods, from David P. Solomon, splendid work. This is truly the essence of precise dieting? Yeah, precise dieting in electronic form, and another great example of the confluence of ancient wisdom and modern technology. I am excited not only to introduce this product to the world, but also for and I to use it ourselves. Whoops, sorry, I know not everyone here can read characters. It is my girlfriend Xiao Mei. So yeah, that reads as Xiao Mei. Alright. Well, and then the other one is I didn't get back to the security nightmare, so I've got a solution for the meat-based printer. Let's open it up, and I'll show you the complicated mess I've gone to. Wow, look at all those controllers. We've got 3 MC4000X's, 1 MC4000, 2 MC6000s, a ROM chip, and the DX300 as I intended. So here's how it works. We had an input from keypad, so it goes into this microcontroller, which is set to sleep until input comes in. And then I do a test comparison with 2 because we're only ever getting in a 1, 2, or 3. In which case, if it's less than 2, it's a 1, so I move a value of 1 to x1 and jump to sleep, so it jumps back to the start. If it's more than that, means it's 3, so I move a 1 to x3 and jump to sleep. And if it's exactly 2, it falls through, and I move a 1 to x2. So, 1 means it's that cutlet style? Or is it steak style? Oh no, 1 is a cutlet style meat. And for this, I had to use the ROM chip because there was no way I could fit enough code in 1 MC6000. So, this sleeps until it gets input from x1, and I do a test equal x1, 1, so I can clear the port. And if it is, it has to be, so I move a 1 at x0, which primes this sub-controller I've set up here, and then I move a 0 into x3, which is over here, which is the address, so that resets the ROM chip address tracking to the 0 position. Then I start a loop, test less than accumulator 7, if it is, move the data value out of the ROM chip to out x0, add 1, sleep 1, jump back to the loop. So if it's exactly 7, I move 0 to the accumulator. And now you might be wondering, wait, that's only 7 units. Don't you need to clear it? Well, I do clear it. But first, this subcontroller, it sleeps until it gets a value from x. And again, test equal x1, 1, so I can clear it. If it is, move 1 x3, which goes into this controller. And then it loops again. Same loop as before. Whatever comes, if it's less, the accumulator is less than 7, move whatever's coming in here out x2, which goes to this DX300. So yeah, that it switches the valve 1, 2, and 3 on and off based on these numbers. Then add 1, sleep 1, jump loop, and once it hits 7, move 0 to the accumulator. But here's how it all comes together. I had to remove the pulse generation pin off of this because I needed the more precise control. So this sleeps until it gets a value in the x0 port, which is now linked up to multiple. Yeah. Okay, yeah, so it's linked up to this one here, linked up to this one here, and linked up to this one here. So then, and again, test if x0 is greater than 0, which it should be. If it is, I move 100 out P1, sleep for 7, then immediately move 0 out P1, and move 0 out X1, which is hooked up to this DX300, and that immediately shuts it off after the pulse is complete. Now then, we'll go back to here, and if 2 comes in, which is the stake style meat, it goes into this MC6000. So that does, it's pretty much the same as it was before, I think. So I set sleep until it gets X1, test equal X1, 1, it should be. If it is, move 1 out X1, so that sets this one on. Then I move 0 out X2, just in case I need to reset it, because, you know, it needs to, but I don't think I would have to. And then sleep 1, then move 10 X2, sleep 2. I could probably erase this line and be fine, but I'm leaving it there just to be sure. Move 0 X2, sleep 1, move 10 X2, sleep 2, and move 0 X2, and then jump back to start, and I can leave it like that because then this also kind of resets it. And then, once again, if it's bacon, it goes out here, and again, I can handle this with just an MC4000X. So it sleeps until it receives data, test equal X01. If it is, move 1 out X2 into this microcontroller, and then I was able to save on space, well, not so much space, but I think I can save on power by starting the move 11x3 here, and then running the loop. So it just fires this one once instead of the 7 times that it would, so it would fire 6 extra times if I placed it in the loop. But yeah, so showing this advances, we're getting an input for cutlet style meat, so it goes like that, and we've got the fat, lean, mix, and yeah, and then this one pulses out and switches off after the last one goes through. So it goes through, we're getting bacon in, we're getting a nice strip of bacon there. Unfortunately, yes, the accumulators do reset. Okay, and then cutlet style steak, so it goes out. And there we have a tasty cutlet style steak. And or that was steak style meat. This is cutlet style meat here. Okay, so that worked. So just run through the simulation. And I don't foresee any problems with this. Yep, there we go. Yeah, I've massively overpriced this. Looks like most common is 10 or 11, maybe? Somewhere from 10 to 12. And still using more power, and I've used way more lines of code. But hey, it creates tasty meat-based products. Okay, from David P. Solomon, I sampled some of the meats from this product and found them all quite delicious. Carl, you should really give it a try. From Wooly Lee, I agree, it's surprisingly better than I expected. From Carl Teskey, make me a fish and chips robot, then we'll talk. Well then, considering that apparently traditional fish and chips no longer uses, what, Icelandic cod? It uses something else now? Synthetic fish meat. But, yeah, that's pretty interesting. Alright, so those were the 2 solutions I've come up with. I still have, well, the prototyping stuff and custom specs. Still have to figure out the pollution sensing window and security nightmare, but I think I'll move on from those for now, because it looks like we have 4 more after that. Okay, but first I've got this new email, Shenzhen Day's the point of it all. From Tilly. So I've talked about the scale of things here, the capacity in all of these factories and ports and markets, and I've asked, where's all this, going? Not to get all existential on you, but it's an important issue, and one that tends to crop up after big economic strides. In some sense, yay, we did it. After a lot of... you left out an A there. After a lot of hard work and sacrifices, we've secured a hugely important place in the world. So now what? Call me some kind of nutter, but engines of creation like these, the ones we have here, just haven't existed before at this scale. It's only now dawning on us what could be done with them if we started coordinating them all. What if someone with some imagination would start doing that? Putting the whole city to work on something together. What could you build that way? Something gigantic and amazing, or something gigantic and scary? Maybe a bit of both? Let's ponder on that one for a bit. Yours, Tilly.